Number 31 says perform the indicated operations and simplify. So I have three radicals that I am adding or subtracting, and they're not perfect squares. I look at each of these and it's not a perfect square. And they're not like radicals. Like radicals, remember, have the same index, and these are square roots, so the index is 2, and then exactly the same radicand, which these do not have. So like this, I could not combine these. But these are all simplifiable radicals, meaning there are some perfect square roots under there. So if you recognize it, just write those perfect square roots. If you don't recognize it, then prime factor each number so that you can see any factors that there are 2 of that you can remove. But I recognize that 72 is 36 times 2, and 36 is a perfect square, so I'm going to write it that way. I recognize that 98 is 49 times 2, and I recognize that 50 is 25 times 2. Now I have perfect squares that I can take the square root of. But again, if you don't recognize those, then just prime factor. Okay, I could have prime factored this all the way down and recognized that I had 2 3s and 2 2s, and it would work the same way. Okay, I take the square root of 36 at 6, so I have 6 times the square root of 2, minus, take the square root of 49, that's 7, times the square root of 2. Take the square root of 25, that's 5, and multiply it by what's out there. 5 times 3 is 15, so it's 15 times the square root of 2. Again, I took the square root of 25, it was 5, I multiplied it by the number outside, that gave me 15. Now these are like radicals because they have the same index, a 2, and the same radicand, a 2. Excuse me. So now I'm going to add and subtract the coefficients. It's sort of like treating your radicals as if they were variables. If I had 6x minus 7x plus 15x, I would just add those coefficients. So I can think of these that way. I have 6 of those square roots of 2. I'm going to subtract 7 of those square roots of 2 and then add 15 again of those square roots of 2. 6 minus 7 is negative 1. Negative 1 plus 15 is 14. I have 14 of those square roots of 2. And that's your final answer on that. Let's move on to B. B says 7 minus 2 times the square root of 3, and that quantity squared. Okay, if you remember the rule for squaring a difference, you can use the rule. That rule is square the first term, that's 49, multiply the first times the second term. 7 times 2 root 3 is 14 root 3, multiply that times 2 and you get minus 28 times the square root of 3. Again, that was first times last. 7 times 2 root 3 is 14 root 3 times 2 is 28 root 3. And then square the last. If I square 2, I get 4. If I square the square root of 3, I get 3. 4 times 3 is positive 12. That's a little bit much to keep in your head, but that's the answer to that. So now let me work that out, doing what I'm guessing most of you are going to do. If you're squaring something, you can just write it side by side and FOIL it. And that way it might be a little bit easier to keep track of those numbers instead of trying to do it in your head. So when I do first, 7 times 7 is 49. Outer, 7 times negative 2 root 3 is minus 14 times the square root of 3. Inner, negative 2 root 3 times 7 is minus 14 root 3. And last, negative 2 root 3 times negative 2 root 3. 2 times 2 is positive 4. Square root of 3 times square root of 3 is 3, or square root of 9 is 3. So now just clean this up. That's 49 minus 28 root 3 plus 12, which isn't finished yet because 49 and 12 can be added together. That's 61 minus 28 times the square root of 3. So whether you remember the rule for squaring the difference and do that, or you set it side by side and do that, you're going to get the same answer. And then of course you simplify it by combining your like terms to get your final answer. And there you go.